Hello everyone, welcome to Detangle. Let's get into today's question. So here we have an electron of mass me. Initially it is at rest and they are telling that it is going a distance in an electric field and it is going that distance in time t1. And also we have a proton mass mp initially at rest and it is going a distance of d, same distance, in time t2. So they have asked us to find what is the ratio of t1 and t2, and we have the options here. So we have got year as an option also. So let's try to understand it. So we have a electric field. Let's consider an electric field, external electric field like this, and they're telling that an electron of mass me is moving in that electric field. So let this be electron, and here there should be positive charges and here there should be negative charges because of the direction of electric field like this. And say suppose there's an electron. So let me take the electron at this point. Say suppose there's an electron like this. So what will happen to that electron if you keep this in electric field? So it is clear that it will be repelled by the negative charges and it will be attracted by the positive charges. So electron will move like this. Now move, how does it move? Does it go with a constant velocity or does it go with a constant acceleration? So that's the first thing to understand here. So as you know that the electrons should move with a force. The electrons are getting force from either side, that is why they are moving. So if there is a force, we know there is an acceleration. So that means we have a constant acceleration in this case. So the electrons are accelerated towards the positive charges. So let's try to figure out what should be the acceleration. So here let me consider the electric field like this from positive to negative to be E. Then I can write the force experienced by the electron to be the charge on the electron, which is Q, times the electric field E, that is equal to m times A. And from that AE, that is acceleration of the electron, and here mass me, mass of the electron. So from this, acceleration of the electron is QE by me. And in the same way I can find, say suppose let's take a proton. So proton of mass mp, so this is the proton of mass mp. So if it is a proton, we know positive charges will repel and negative charges will attract. So the proton will be accelerated like this. So I can write, same way I can write the expression for proton as ap is equal to QE, charge of the proton is plus QE divided by mp. The electric field is same, mass will be mp. Now here if you got a confusion like here the electron charge is negative, I'm not taking any negative sign, such confusion. So it doesn't matter. Why? Because the charges will be negative and positive, that is charge of electron is negative q, charge of proton is plus q. Why? Because these are scalar quantities. But that negative if I put in this expression, that is acceleration, we know acceleration is a vector, that is here if I put negative, it just means that it is in opposite direction. So that I have already made an idea of it, right? So if the proton is moving in this direction, say suppose this direction is positive, then the electron is moving in this direction, so it is negative. So that negative just means that these are in opposite direction. So that is why I'm not putting any negative, I'm just taking the magnitude of these values. Okay, now in the question they have asked us to find what is the ratio between t1 and t2, and I've already got acceleration. So basically I need to find a relation between t, a and distance. Why? Because here they have told it is at equal distance. So out of Newton's formula, that is v is equal to u plus at, and v square is equal to u square plus 2as, and s is equal to ut plus half at square. So out of these Newton's formula, the appropriate one will be this one. Why? Because they haven't told anything about v, the final velocity, but they have told that the distances are equal, and we know what is the acceleration. And also one more advantage is they have given the initial velocity is 0, which means that this term will be going to 0. So here I get the relation between t, a and s. So if I connect to this, then I'll get the ratio t1 and t2. So I'll just do that, as s is equal to half acceleration of electron t1, they have given time for electron as t1, and for proton I can write the distance as s equal distance. So this will be half AP into T2 square. Now since the distances are equal, if I divide both of them, so SS cancel, half cancel, so I'll be getting T1 by T2 is equal to square root of AP by AE. And also I know what is AP and AE, so if I substitute this AP and AE in this expression, I am going to get a square root of, here Q cancel, EE cancel, and this ME will come up, so I'll get ME by MP. So from the options, correct option should be C.